Okay, folks, today we're going to talk about binary, ternary, n-ary fact types, or the number of entities that play roles together. Now, I'm going to talk about binary first because we've already seen that. We've seen the example of a person playing a role with a hobby that we talked about last time. So I'm going to go person. We're going to uniquely identify that person with an ID. And then we're going to give it a verb, and then we're going to say hobby, and we're storing names of hobbies, like that. So that's our fact type. It's atomic, it's elementary, it can't be broken down any further because it's simply two entities playing a role together. Now I should point out that we actually do have unary fact types. We come across these quite frequently in database design. And I'll talk about that first. In real life, there are a number of unary fact types. Now, by unary, what do I mean? I mean that the person simply plays a role. And so, or the entity, I should say, plays a role. So we could say person with ID is married. So it's quite common to have these sorts of unary fact types. And you could probably think of a whole bunch of examples. Give me another example. Doesn't have to be a person, could be any other entity. The international book number, the international something or other book number, probably standard book number. So every book published has an ISBN, and you'll see it on the barcode of the book.
International standard book number?
Yep. Nice. Okay, so these unary fact types, you can imagine those. Sorry, I haven't got my iPad sorted. You can imagine those as a circle with a box. OneNote. Here we go, right to here. So you could think of those things as I want to draw in black. Thank you. A unary fact type could be just a circle that plays a role. So a person with an ID. However, they're not very useful for putting into a database. What we can do is we could turn those into a binary fact type. So let me organise this a little better. So we've got unary fact types. So what we're going to do from now on is we're going to concentrate on binary and above. Binary fact types. And so as you see there, how we turn a unary into a binary, we simply make up another entity.
So just double checking, what's a fact type?
It's a fact that we're trying to model in a database. Fact that the person with an ID has a marriage status. Badly drawn, but you get the general idea. So a person has a marriage status. Okay. Now, if you want to, what we can actually do is enumerate with square brackets. Married, single, what else we got? Divorced, or maybe D for de facto. It's complicated. You can actually enumerate those. Fairly obviously, gender is another one. We could describe gender as a unary fact type, where person is male, person is female, person is something else. Complicated. Or we could actually have gender as an actual sort of a pretend entity. And that's what we tend to do. We tend to deal with binary fact types and above. Okay? Nice and simple. And then, of course, we have uniqueness constraints on that. So a person can have how many marriage statuses at any point in time? Just one. That marriage status could be the marriage status of multiple people. So that's a one-to-many relationship. See how that works? Okay, that's binary fact types. There are times you'll come across in your life, creating databases, where you have to use ternary fact types. Now, a ternary fact type, ternary simply means three. So we're looking at three things that can't be pulled apart. Let me give you a good for instance. Student with student number. Well, let's go this way first. Let's go studies. Subject, which would probably have a subject code. Maybe we call it subcode. By the way, you notice that I'm using the underscore method of separating things. That is fairly standard in conceptual schema design, which is what we're doing now. It's also fairly standard in database work to use the old underscore instead of a space. It's quite common. Maybe I should have written it around the other way. Result code, all codes. That's a ternary fact type. Now I know it's a ternary fact type because I cannot split that without losing information. I can say a student studies a subject, but I've now lost the result they get. I could also say student achieves a result, couldn't I? But if I don't know what subject that's in, it's a useless piece of information. You don't get like A, B, C, D overall. That's per subject. Now, there's a couple of different ways we can draw these using an entity role diagram. We could simply put three of these boxes together in the middle. For instance, I'm just going to shorthand everything, student. We could actually put three boxes together like this. Subject, which means that would be a result. And that's perfectly legitimate. Each of these guys has a socket that connects to a plug. They're all plugged in together because they can't be separated. Now, the problem we face is, let's talk uniqueness constraints. So, you are a student, and how many subjects can you study? 7, so multiple. So that's a one student to many. Subjects can be studied by just one student, is that right? Oh, that just became a many to many. So I need to draw a bar across those two. So if I draw it like that, is that many to many? Not really. It's got to be a continuous line. That is our symbol for one-to-one. All right, let's redraw this so that we got subject and student together. So I'm going to go, by the way, that's wrong. I'm going to go subject, and this time I'm going to, student, I'm going to connect them to subject and then result out the end here. So now I can define my many to many, but we haven't finished. So how are we going to then do our uniqueness constraint for a result? So do you get this, could you possibly get the same result in more than one subject? Fairly obviously, yes. You could all get A's in every subject. So what we do there is we do a second uniqueness constraint, 1-to-1. Now that gets confusing and that's not easy to read. So that's not how we handle a ternary. What we do is we do this. Student studies a subject. That is a many-to-many relationship. Oops, sorry. Now what I do is I look at that combination of student and subject and consider that to be an entity in itself. The actual relationship between you and that subject is an entity in itself. So I'm going to draw a circle around it. I'm creating a new entity, the combination of you with your subject. And for each of those, you get a result. This is what we call nesting. And so I've turned the concept of you in a subject into an entity of its own. Combination of those two things. And then, from that, you get just one result. But that result could be the result of many student-subject combinations.
So in this instance, student and subject are always in it? Is that...
Always in it. They always have to be combined together when we're talking about results. So obviously this is a final result because I can hear the gears turning. Somebody's going, but we get a result every term. We'll talk about that when we talk about N-ary. Okay, so when we have this nested situation, if the relationship inside the nesting, inside my extra circle, is anything but a many-to-many, you're wrong. I'll give you another for instance. If you end up with, I don't care what the actual entities are, you're drawing out your circles and you end up with this arrangement, and you go, okay, that relationship there is a one-to-many. If that's the case, it's incorrect. Because this guy here, which will be a one-to-many that way, could have connected directly to that guy without losing information. Okay? Likewise, this relationship here will always be a one-to-many. Except never. 100% of the time, it's a one-to-many. If it's anything else, you've modelled it incorrectly. Now, that's the basic rule of ternary fact types, where three things simply can't be split without losing information. Now, I mentioned before about different terms, getting different results for different terms. So that's what we call an N-ary, any number fact type. Now let me give you a, for instance, we'll use the same example we've been using. Student studies subject in term achieves result term is just a number, of course, subject code, student code or student number or whatever it is. Here we have four things that can't be split apart. So now we're not talking about your overall final result. We're clearly talking about your term by term result. Okay? So here we have 4 things and you can't split them. In that case, what we do, rather than drawing, circles with 4 boxes, oops, wrong pen. Here we go. Rather than drawing this sort of nonsense, we got something up there and something down here and all that sort of thing, which would be ridiculously impossible to put uniqueness constraints on, we nest again. So this time we've got a student studying a subject. In a many-many relationship, we go, they study that subject in multiple terms, achieving a result for each term. And again, that relationship off to result, that relationship there will always be a one-to-many. And any relationship that's inside, I'll change colour, any relationship that's inside a nested situation like that is going to be a many-to-many.
But so it's saying the term can have multiple results, but the result can only have one term?
No, the other way around.
So the term can only have one result?
So a student in a subject in a term can only have one result.
Yeah.
Now, N-ary literally means N-ary, any number. So what about component results for the different criteria? So you would see that we would have 5 things involved in this relationship. Just think of, for a moment, a school timetable. So a particular class is in a particular room, but only in a particular period on a particular day with a particular teacher. All of those things can be changed. Okay? Only then do we have a unique class for a timetable. That's 5 facts pulled in together. And so some of these can get quite complex. And right at the end of this whole discussion, I'm going to show you the optimal normal form algorithm, just in case you want to know where we're heading. This is it. I've got a space here for the screen recordings. We're going to talk about doing the circles for the whole database next. Then we're going to talk about mandatory roles. And then finally, we're going to look at optimal normal form algorithm over the next 4 lessons. And this is a way that you can actually make the best optimal normalization, it's called, or relational schema is our result that we can then turn into an SQL database. Okay, questions about binary, ternary, and n-ary?
I wouldn't be here tomorrow, so that would just be
That will be in OneNote, yep. And I'll do a screen recording on putting this all together for a particular universe of discourse later. All right, let's jump back to what we did last time, down the bottom here. Let's have a look at some answers for these questions. So it says, Jill's car needs a new rear tyre, she's taking it to my car. Remember how we said that? Trying to figure out what those sentences are is a little bit weird, isn't it? Until we realise that there is a universe of discourse wrapping this whole thing up. And we talked about that universe of discourse being the My Car database. Okay, so if this is the My Car database, it kind of takes this entity out of the equation. We never have to record My Car in a My Car database. What we do record then is what?
Jill, like her name and stuff?
So what is she?
Jill.
To My Car, what is she? Customer. How are we going to uniquely identify a customer? Some form of? We could go has name. Bit redundant, but we could do that. What's next?
car, like
So we need to capture
an ID.
customer, generally with the same ID, owns vehicle, because it could be a bike,
So would you have
with what? VIN? I think we talked about that, didn't we?
So would you have,
Vehicle identification number, unique number for every vehicle on the road. It's better than a rego.
would you have what's wrong with that vehicle?
So, yes,
Missing.
vehicle with a VIN. I don't know what you call it. If it was my car, you'd probably call it a job. And you'd probably have something like a job number.
Couldn't you just have like a job name and could just be? 'Cause
Tyres. If this was a database you were making, no, you'd definitely give it a job number, because that job number then would be related to, I don't know, is for issue. Oops. So that issue could be a piece of text. More than likely, you would have predefined pieces of text. So that'd be like an issue number that then looks up into another table of list of all the things we do. Chances are that job number will have multiple issues on it. So they might be changing the oil and changing a bad tyre. They might be giving it a tune-up and, I don't know, spit polishing the steering wheel. I don't know what they do. That type of thing. That job number would then be related to total cost. That job number could be related to each of those issues in a many-to-many relationship. See where we're heading with this stuff? It's a lot more complex. Another one I'll draw your attention to is that job number would be for a particular date, because we want people to come back. We want them to have multiple jobs. Might even have time. Make it date time when it's booked in. See how this stuff builds? Brian's a managing director. He is 53 years old and is in office, blah, blah, blah. Again, just on its own, bit tough to do that. When you realise it's a business database we're talking about now an employee. Yep. An employee, and it'll have an employee number, presumably. Has name. We used to put in like an example in the brackets. I've changed it and simplified it just for these days rather than make it too complex. Employee has name. Employee, we are obviously recording their age. I used to also let people do this for things like that. Age, which is a number, just use a hash. Employee has office 2312, and again, that could just be a number.
Employee has job.
Oh, I forgot that whole main thing, didn't I? Employee has, I don't know, could be a title. You notice how a lot of these second things, second entities, I'm using the same name as the actual entity type, title and title, name and name, because they are secondary. The main thing here is this guy. So when we get together next time, these are all binaries. I did think of a ternary for up here, but I've forgotten it. That's okay. When we get together next time, we'll draw the circles for these. Okay, and we'll have a look at that sort of thing. Yes, sir.
Wouldn't you use date of birth?
And I did mention that to you last lesson, didn't I? You wouldn't use age. You would record date of birth.
Yeah.
So let's do that. Let's
Why is that?
because age changes. We can always calculate a date of birth. You could do that
That means we did.
and derive. That's actually a good thing, because we're deriving his age from the date of birth, and I'll show you how to derive fact types on our diagram.
But in this instance, with that information, we couldn't really do an exact date of birth because we don't know when we got it.
No, that's right. So our database needs to record date of birth so we can figure out what his age is. Bell's about to go, so we'll leave it there. We'll have a look at that one. I think that's a whole lot simpler. We'll get So we'll end that there. I'll pop this up. Oh, by the way, you see that I've changed this now. This is a YouTube. I've made myself a channel. I'm now a content provider. So I've thrown up the last video because Seth couldn't actually access it through Stream. Microsoft Stream won't allow guests. Only people in our organisation, which is annoying. So I've thrown it up there in YouTube for your viewing pleasure. And I'll throw this one up sometime today as well. What are you doing searches for me?
Yeah, like 2 months.
That's not mine. Have a great day, gentlemen.